Welcome to Nokia Rooftop Wireless Router Model R242 installation training. The information we will give you in this video will help you to install the equipment at a customer site. You can find further supporting information in the hardware installation guide. There are two basic types of antennas available: omnidirectional and directional. Omnidirectional antennas radiate spherically, providing equal coverage in all directions. They are best suited for multi-point links and are typically used at all forwarding sites. Because they receive and transmit signals in all directions, they are the preferred solution for most installations. Directional antennas focus their RF beam in narrow patterns in one direction. Directional antennas provide communications over longer ranges than omnidirectional antennas, but are much more limited in the areas they cover. Directional antennas maximize link distances. They are also effective for simple, dedicated point-to-point links. It should also be noted that directional antennas limit future growth of the mesh network and prevent the wireless router from repeating signals to other units. They should be used only where an omnidirectional antenna will not work. Antennas are also polarized. Polarization refers to the direction of antenna element alignment. For antennas to properly communicate with each other, the elements must be aligned in the same direction. Directional antennas have an arrow on the back panel indicating vertical polarization. They radiate from the front side and away from the mounting bracket. Directional antennas can be vertically or horizontally polarized. Rooftop will always use vertical polarization. An omnidirectional antenna, which will be used in this installation, is vertically polarized and therefore can only be mounted vertically. Nokia recommends two types of RF cabling for wireless router and antenna installations. The first is a flexible standard loss jumper cable, also known as a pigtail. They are short, usually less than 5 feet. They are flexible cables that connect amplifier components with the antenna and wireless router, or are used to connect the low-loss RF cable to the wireless router. The second type is the low-loss RF cable. It is a semi-rigid, low-attenuation cable for long cable runs. Cables should be selected based on providing the lowest loss at 2.4 GHz when the cable lengths must be long or when antennas are located long distances apart. Determine if there are line-of-sight paths for each proposed link. Line of sight exists if there are no obstructions, for example, trees or buildings between the antennas. For best results, there should be no obstructions between the two antennas. For long-distance paths, there should be no obstacles close to the RF path. A quality antenna installation requires clear visual line of sight between antennas, clear radio line of sight between antennas, proper antenna and cable selection, and mounting based on the site requirements and limitations. It may be necessary to install a mast in order to clear physical obstacles. A visual line of sight exists when an imaginary straight line can be drawn between two antennas without passing through physical obstructions. Verifying visual line of sight is the first step in planning. This means the observation points must be high enough to allow the viewer to see over any ground-based obstructions. It is not always necessary to have visual line of sight. For short distances, wooden structures and non-metallic objects have little effect on RF signals at this frequency. The critical factor is radio line of sight. You must verify a clear radio path. The goals of a site analysis are to determine feasibility of RF links at each site and to determine the antenna and cable requirements. When setting the latter, care must be taken not to damage the property, including gutters and landscaping. First, determine the feasibility of an RF link to other sites. If the site has good links to other sites, it can be a forwarding system for other Internet radios in the network. If it can link to just one other site, it will be able to access the Internet, but it cannot forward signals for other wireless routers. survey all obstructions to potential sites. Whenever possible, use an omnidirectional antenna. This assures maximum connectivity and allows the unit to forward packets for existing and future needs. If the wireless router requires a single link to another wireless router, use a directional antenna. Determine the RF path between the antenna at the site and the antennas at other adjacent sites. For a directional link with a single antenna, there is only one RF path. For an omnidirectional antenna, determine all RF paths. The RF path can be determined by knowing the relative bearing from the current site to adjacent sites. Using local maps, a GPS receiver, and a compass can be helpful. The feasibility of an RF link can be estimated based on distances between the potential sites, the line of sight for the RF paths, antenna RF gains, cable and connector losses. Determine the antenna location and maximum possible antenna height. The height of the antenna is often dependent on the physical limitations of the site. For example, an antenna mast can be placed on top of a rooftop, or an antenna can be installed on an existing structure or tower. After determining the feasibility of the RF link, consider the following: hardware and tools necessary to complete the installation, wireless router installation location, the RF cable routing between the wireless router and the antenna, power source location for the wireless router, Ethernet cable routing, and antenna grounding and lightning arrestor requirements. Basic tools and supplies needed for a Nokia wireless router installation include wrench and screwdriver set, cutting tools, power drill, ladder, weatherproofing tape, silicone sealant, hand vacuum, zip ties, RJ45 crimping tool, patch cable test tool, and a laptop computer with Windows operating system and Nokia Wireless Router Manager software loaded. Suggested installation components include jumper cable, small length of 1/4-inch RF cable, low-loss RF cable at various lengths, lightning protection hardware, antennas and antenna mounting hardware, routers, power supply units, RJ45 cable, and wall jack faceplates. Suggested special tools include binoculars, a GPS, and a SiteMaster or network analyzer, which is used for SWR testing. Good weatherproofing is the key to antennas that work well in all weather conditions. If water or moisture enters a cable or connector, it significantly reduces signal levels and often ruins the cable and connectors. Weatherproofing outdoor RF cables and connectors is a requirement for good short and long-term system performance. Required weatherproofing supplies include weatherproofing tape, scissors, and silicone sealant.